Hello, my name is Ethan Souza, and welcome to Finding Planetary Transfer Windows with MATLAB. When I started this project, I set out with the idea of creating a program that would calculate the optimum transfer windows between Earth and Mars, as well as the delta V required for that, and then it would ask the user to input their intended launch date and the mission's planned delta V, which is the change in velocity. It would then compare what it had calculated for the transfer windows and the delta V needed to go between Earth and Mars, and then tell the user if their launch date and the delta V they had entered would give them a correct approach. This relies on home and transfer windows. Now, what are home and transfer windows? They're a way to go from planet to planet, or from one planetary body to another while consuming the least amount of fuel. This is not exact because home and transfer windows assume that everything that each planet or moon or whatever is in the same plane, which is just not the case. And it also doesn't take into account the gravitational effects on of other planets and moons and everything else on the target planets. Now this is an example of a home and transfer window. It specifically from Earth to Mars. It showing how the trajectory for a potential mission would go. It relies on the target planet being a certain angle ahead of Earth when the mission is launched. So to create this, I relied heavily on the Aerospace toolbox, specifically the Julian date function, which changes the Gregorian date into the Julian date, and the planet ephemeris function, take which is which calculates the position, velocity, and whatnot of different planetary bodies at a given time. The applications for this it increases the efficiency of interplanetary missions. So, for example, if you were to launch a non-optimum window, then you would need more fuel, which increases the weight, which increases the amount of fuel you need, which is just a vicious cycle of more weight, m meaning more fuel needed to send that weight to where it needs to go. But if you have like the optimum launch window, meaning the lowest amount of delta V you need, then you don't need an an increasing amount of fuel to do course corrections and go and brute force your way to your target planet. So what I learned from this was how to use various parts of the Aerospace toolbox, like, as I said, the planet ephemeris function. I also learned through this course and this project how to integrate functions into a program. So next steps for it would be to add new functionality for more planets because that was the initial plan actually. I had wanted to do you know, planetary transfer windows to each planet in the solar system. Another additional step would be gravity assist. So this is another way to reduce the amount of delta V. Is if you're going to someplace like Pluto or something along those lines, you might want to use gravitational assists, which you would that which what you would do is go launch using the home and transfer window to a different planet and use that and go close to the gravity well, up into the gravity well of that planet, and use its energy to add more velocity to your craft, thereby increasing the size of your orbit with less effort on your end. It's how Voyager got interplanetary without having a ludicrously sized rocket. It's also something for later would be changing the choice of starting planet. So instead of just Earth, you'd be able, in a future version of this, you'd be able to say, I want to launch from Mars to this other planet. And also, I would include an animation like the one showing the example of the home and transfer window from Earth to Mars. And I would just overall make it the code more organized and more professional. Thank you for your time.